In February 2024, the British Columbia Civil Resolution Tribunal heard a small case about a grieving passenger and an airline chatbot. The bot, asked about bereavement fares, fabricated a 90-day refund policy that did not exist. The airline refused to pay. A tribunal and a tarmac of corporate counsel were watching. Air Canada's defense was novel. The corporation argued that its chatbot was a separate legal entity, responsible for its own representations. Tribunal Member Christopher Rivers called that submission remarkable and rejected it. He ruled that the airline could not separate itself from the chatbot. The damages were small. The precedent is not. Every probabilistic wrapper in production is now a legally binding employee, and the era of the black box defense is over. Standard remedy on offer is retrieval-augmented generation. Wrap the model, pipe in the policy, let the bot read it back. The Moffatt case shows why this is not enough. The chatbot did link to the correct refund policy. It still summarized that policy incorrectly. Providing the right document does not guarantee adherence to it. Vector similarity is not logical relevance. A query about refunds can retrieve refund processing times instead of refund eligibility. And even at the frontier, hallucination rates run between 0.7% and 25%. At 1 million customer queries a month, that is 7,000 potential regulatory violations every month. Veriprajna's answer is not a bigger model. It is a deterministic action layer, middleware between the user interface and the language model that silences the model on every transactional intent. 4 phases. Phase 1, semantic routing. The user's query is encoded into a vector. The router measures cosine similarity against a list of restricted topics: refunds, warranties, pricing, privacy, liability. If the similarity exceeds a strict threshold of 0.85, the query is intercepted before it reaches the model. Phase 2, strict function calling. The router does not let the model write the answer. It hands the query to a typed function, check refund eligibility, with arguments ticket ID, purchase date, travel date. The function is Python. The function is SQL. The function is code, and code does not hallucinate. Phase 3, the truth anchoring network. Before any answer is rendered, it is validated against an OWL ontology or a knowledge graph. If a customer asks about drug interactions, and the graph carries a severe interaction edge between drug A and drug B, the model is forbidden from generating any contrary text. The answer is constructed from the graph, never authored. Phase 4, the silence protocol. When the user's question falls into a policy gap, the model is silenced entirely. The system answers, "I cannot answer that directly. Let me connect you with a human specialist." A null answer is safer than a fabricated one. Conversation belongs to the neural system. Decisions belong to code. The model proposes, the policy disposes. Consider the same query through both architectures. A passenger asks about a bereavement refund. The probabilistic wrapper, the system Air Canada deployed, replies, "Sure, just submit the form within 90 days. That is the hallucination. That is the judgment." The deterministic layer routes the same query to a typed function. The function checks ticket status. The ticket has been flown. The function returns no underscore refund. The voice layer renders. Our policy strictly prohibits refunds after travel, reference, tariff rule 45, same model, same input, auditable output. The financial backdrop is heavy. Global losses from AI hallucinations reached $67.4 billion in 2024. Forrester puts the mitigation tax, the cost of humans verifying AI work, at $14,200 per employee per year. The market for hallucination detection tools grew 318% between 2023 and 2025. The industry has already admitted the diagnosis. The Moffatt Tribunal was simply the first to write it down. There are now 2 architectural stances toward enterprise AI, and they carry different liability profiles. The wrapper stance, a thin user interface over a foundation model, relies on prompt engineering. It is vulnerable to prompt injection. It is fragile under model updates. It binds the corporation to whatever the model says. It is a liability engine. The deterministic stance, semantic routing, function calling, knowledge graphs. Output rails is auditable, traceable, and compliant by construction. It maps cleanly to ISO 42001, to GDPR Article 22, to the EU AI Act Article 14. It is not cheaper. it is insurance. Is your chatbot writing checks your business cannot cache? We build the firewall, semantic routers, typed functions, knowledge graphs, silence protocols. We replace probability with policy. The 18-page brief walks the full architecture, the legal frame, and the engineering blueprint. Read it before the next ruling.